Hi, boys and girls. This is your instructional video for section 5.3, scatter plots and lines of fit. I think this will be a short and easy section for you. I'm really glad this fell on this week since it's a short week, and I think that you'll enjoy it. We've been through some pretty strenuous stuff lately, and it'll be nice to have something a little simpler. Scatter plots are interesting little things. We create them to tell if there is a correlation between two things. Like, for example, you might expect that as people get taller, they get heavier. Okay, and that there is a correlation. The taller the person, the usually heavier person. Another correlation is the faster you drive, the shorter time it will take to get there. Unless, of course, the cops pull you over, which I guess could happen. Also, the slower you drive, the longer it takes you to get somewhere. Those are things that have correlations. Some things don't have correlations. Well, I've got these example ones here. For example, this one here, does studying increase your grade? Here is the amount of time they spend studying in hours, and here's their math grade. So, yes, it would appear that the more you study, the higher your grade is. This one this is what you call a positive correlation because it's going up. Up is positive, okay? This correlation is going downhill, okay? This is a negative correlation. Weekly hours of video games, weekly working hours. So, if you're working on your schoolwork, the more you play video games, the less you work on schoolwork, okay? So that's a negative correlation. And here is a scatter plot with no correlation whatsoever. There is no connection between the number of pets you have and your shoe size. Well, we wouldn't expect there to be, but so over here you get your vocabulary. There's a whole bunch of vocabulary. Positive correlation means it's going up, and it does have the two things are related. Negative correlation means it's going down, and the two things are related. No correlation means not related. Okay. Bivariate data is just this. It's data where you're comparing two things. That's why it's bivariate data. Okay. Okay. Bivariate data consists of pairs of values. A scatter plot is a graph of bivariate data that consists of ordered. Well, I'm already bored with that paragraph. Basically, this says what I already said. Two things that are related, as one goes up, the other goes up, form a positive correlation. Now let's think about this, what we know about slope. Isn't this a puff positive slope here? Isn't that what that would be? Wouldn't this be a nice negative slope? And then this is no correlation. The two things are not related at all, okay? Notice that in the graphs for positive and negative correlations, many of the points form clusters of points that slope upward or downward. Points outside of the clusters are called outliers, okay? So if we had a point, and there's not, like maybe that's an outlier, but if you had a point like out here, some random, some random one that didn't really fit, this is called an outlier, okay, because it lies outside the usual. Okay. All right, example 1. Evaluate the correlation. You're going to be shown graphs of scatter plots and asked to say, is it a positive correlation? That's an uphill. A negative correlation, that's a downhill, or no correlation, scattered all over the place, okay? The scatter plot displays the height and weight of New Orleans Saints football players. Determine whether the scatter plot shows a positive, negative, or no correlation. If the correlation is positive or negative, describe its meaning in the situation. Okay, when I first looked at this, I'm kind of like, it's not a great correlation. It's kind of, I prefer a tighter collection of points, but they say it definitely shows a positive correlation. This means that as the height of the player increases, so does the weight of the player. Okay, there's always a chance that you got a really tall, skinny guy or a really short, heavy guy. Those would be your outliers. But for the most part, the taller the player, the more they weigh. Okay, so it says the scatter plot shows a positive correlation. As the height of the football player increases, weight usually increases as well. Okay, excuse the handwriting. Writing digitally is not easy. Okay, this is kind of an interesting one for me. My husband was a phone man for many, many years. And this is true. Telephone usage, landline usage has really decreased in the United States. If you would extend this even beyond, this is 2013, I bet by 2020, we're way down here. The scatter plot displays the number of landline telephones in the United States. Probably most of you don't even have a landline anymore. Determine whether the scatter plot shows a positive, negative, or no correlation. Okay, this shows a negative correlation. This is a nice negative. Okay, so it shows a negative correlation. And that means as time increases, the number of landlines generally decreases. I think I'd be interested to see a scatter plot of time and payphones. You're hard pressed to find a payphone these days. All right. So now, once you have a scatter plot, it can be useful to make predictions. Okay. So if you have a scatter plot, it's got a good strong correlation. You can draw what is called a line of best fit. So say we have a scatter plot and we've got a bunch of dots like this. Okay. We can draw a line of best fit right through the center. It's a line that fits the points as best possible, the best possible fit. And they call it a line of best fit. Then if we wanted to make predictions for points that we don't have, we could. We could predict what the cost is going to be like at any point on, here and here. We could predict things. And so that's what we're going to be doing here. We will make a scatter plot. We will draw the line. Then we will write an equation for the line, okay? We're going to pick the 2 points that are closest to our line of best fit, and those are the 2 points we're going to use to find slope, and then we're going to write an equation, okay? With the equation, we can make predictions. And depending on, they're going to say, how good of a prediction is that? Well, it depends on the scatter plot. If it's just loosely correlated and these points aren't real tight, it's not a real accurate prediction. The tighter these points become, the more accurate our prediction is. Now here's a big one, linear extrapolation. That almost sounds like a form of torture or something. Linear extrapolation is the use of a linear equation to predict values that are outside the range of data, okay? Linear interpolation, I hope I said that right, is the use of a linear equation to predict values that are inside the data range, okay? So extrapolation is, okay, so if this kept going, what about in 2050? What's it going to look like, or if we say, okay, well, what do we predict 2017 was like? And we find it right in here. That's interpolation. These are not words that you will use frequently. I am a math teacher, and I have to refresh my memory every time I teach this because I don't use them either. So don't get too hung up on that. Example 2. Oh, wait a second. Hang on just a second. Sorry, Miss Segrist needed me. Okay, example 2. Write an equation for a line of fit. Now, they have pretty much done this for you, okay? They've given you these points here, and they have graphed them for you, okay? This is the average cost of jet boats in the U.S. Okay, well, you would expect the cost to go up, inflation and stuff, Over time, the price of jet boats goes up. Jet boats are expensive. Okay, so they graphed all the points. That's step 1. Step 2, draw a line of fit. The line of fit is a line that goes through the data that most closely matches the data. Okay, now from that line of fit, we write an equation. Here's where it gets interesting. The line of fit passes close to the data points 5, 25,108, and 10, 32,752. So then they use those 2 awful, disgusting looking points to find the slope of the line. Okay, here they've got the slope of the line, 1,528.8, which means that every year the average price of a jet boat increases by $1,528. Okay, so now that we have an M, let's use M equals that and one of the points to write an equation. So we're using point slope form. And we're going to write an equation in point slope form. From that, we change it to slope intercept form, okay? As we don't really know where the y-intercept is, we're going to go from point slope form and change it to slope-intercept form so that we can approximate the y-intercept. That's what we're going to do. Okay, so now we have our equation. Use the evaluation to predict the cost of a jet boat in 2005. All right. Well, the graph said number of years after 2000. So that means in this example, X would be 5 because 2005 is 5 years after 2000. Okay. So you would substitute 5 here, and I haven't done any of this math in advance. X equals 5, but it looks like they've done it for me. So we would have this number times this number is this number, plus this number is 25,108. So we predict that the cost of a boat in 2005 was about 25,108. That's interpolation because that value was on the graph. It was in the points that we had. But now we're going to do extrapolation. We're going to predict the cost of a jet boat in 2025, the future. Okay, well, 2025 means that X is 25 now. Why did they write this twice? I guess you would put X here maybe, and then you would put 25 here. I don't know what they want. Substitute 25 for X, and they've done most of this for us. Let's see, and apparently according to them, 684. A jet boat in 2025 will cost you approximately $55,684. If you guys are thinking that in 5 years you might be in the market for a jet boat, I hope you get a job in the math field so you make a lot of money. And I'm not talking about teaching math, I'm talking about like engineering and stuff. Okay, never mind. Okay, so here we have a check. Animals, the data show the amount of milk that a baby goat needs by its weight. Okay, so we would expect that as a baby goat gets bigger, it will need more milk, right? As dogs get bigger, they need more food, so it makes sense. So here we have the weight of the goat in pounds and the amount of milk that it requires to stay healthy. Use the data points 1020 and 5080, which are contained in the line of fit, to write an equation of the line in slope-intercept form. Okay, so here's what we're going to do. We are going to use the 2 points they gave us, 1020 and 5080. Okay, it's about to get noisy because the bell's going to ring, and then Mr. Mesher is going to declare the sunshine rule, which is his secret way of telling us we can leave early. Because it's 2:10 right now, and normally we have to stay till 2:40, but on Fridays he doesn't make us stay till 2:40. Don't tell anyone I told you that. Okay, so we got to find the slope. All right, second y minus first y over second x minus first x. 80 minus 20 is 60, 50 minus 10 is 40, and this reduces to 3/2. Okay. All right, so 3/2 is our slope. So now we can use the slope and a point. All right, what point do we want to use? Let's use the smaller one. Let's use 1020 as our point, and our slope is 3/2. And we're going to write an equation in point slope form. Okay, you remember point slope form is y minus the y coordinate, 20, equals the slope times x minus the x coordinate, which is 10. From here, we can write an equation in slope-intercept form. We'll need to distribute this 3/2. Y minus 20 equals 3/2 x. Let's see, 3/2 times 10. The 10 and the 2 would cancel. Here's what I'm doing in my head. 3/2 times 10 over 1. I'm saying those would cancel, giving me 1 here and 5 here, which gives me minus 15 because the negative, this was a minus, okay? Now I just have to add 20 to both sides to get y by itself. And it gives me that y is equal to 3/2 x plus 5, okay? And so here's slope-intercept form, y equals 3/2 x plus 5. Oh, that was bad form. I was getting kind of lazy on my writing here. Let me write that in better form. 3/2 x, there. I didn't want the x to look like it was in the denominator. Use the equation from part A to predict the amount of milk needed for a 17-pound goat and a 55-pound goat. Okay, so they're saying let x equal 17 and let x equal 55. Interpolation, extrapolation. All right, so we would have y equals 3/2 times 17 plus 5. At 51. Y equals 51/2 plus 5. And 51/2 would be 25.5 plus 5. So 30.5. 30.5. Okay. I'm going to need some space to write because I've got to do the 55-pound goat now. Erase some of this stuff here. Look at her getting carried away. Isn't this fun? I'm having fun. Okay. Now we need to do a 55-pound goat. So we have y equals 3/2 times 55. I might have to whip out a calculator here. Plus 5. Yep, let me get a calculator. It's Friday. It's 2:15 on Friday. He still hasn't declared the sunshine roll. What's going on with that? Should have done that by now. 3 times 55 is 165. So we have y equals 165 over 2 plus 5. 165 divided by 2 is 82.5 plus 5. So this little guy needs 87.5 ounces. Okay, so just to review, in this section, they will give you points. They will ask you to predict, make predictions. That's the biggest type of problem that they're going to give you. Then you will graph, you'll make a scatter plot, and then you will draw a line of best fit. You will find the 2 points that most closely touch the line and use those as slope to write an equation that you can use to make predictions. All right, so you have that to look forward to in the practice problems. Thank you for watching. I went easy on the secret word this time. I got a little lazy. I'm running out of time. It's time to go home, you know. So the secret word is purple. You know what? Purple is my favorite color. You would think green would be my favorite color because I love frogs, but frogs are just my favorite animal. Purple's my favorite color. So I'm rambling, and there's no reason to make this video take any longer than it is. I'll see you on the practice one. Bye, guys.